Here's two examples of simplifying radical expressions or expressions with square roots in them. The first one we're going to go over has variables underneath the square root. The second one is in a big fraction. So we're going to kind of look at the differences and similarities of the two. And anything that we do with a variable can be applied to fractions, and anything we do with the fractions can be applied here as well. So starting off with this example, anything we move to the outside of the square root, we're going to end up multiplying by 5 because we're multiplying all this together. We're going to start with the 75. And typically I like to look at, is there a square number that divides into 75? Remember, the definition of a square number is a number that you can evenly take the square root of. If you're not sure, you can always create a factor tree with 75 and say that 5 goes into it and 15. And then 15 can be split up into 5 and 3. That 15 now goes away, and the 5s go together and form as a pair. Personally, I feel like it's easier to say, okay, 75 is the product of 25 and 3. And it's the same thing as the square root of 25 times the square root of 3. And the square root of 25 is 5. So if we take our radical, our square root, I have the 5 on the outside. That 5 comes from up here. And then I have this square root of 25 that I get below. So times 5. Now this square root of 3, I cannot take the square root of 3. So that goes inside the square root. It stays there if you can't simplify it. So to summarize, this 5 stays on the outside. 75 splits apart to square root 25 and 3. You can also look at the pairs because the square root of 25 is 5. So another 5 goes on the outside. That's right here. This is what's left over, so this goes on the inside. Now we're going to look at our variables. I'm going to be kind of limited in space here as well, at least I believe so. Yeah, I'm not able to move all that. So looking first at the x to the 4th power. Personally, I think this is kind of the easier part because all you have to do is divide that exponent by 2 in order to take the square root of it. X to the 4th power, the square root would be x squared because x squared times x squared is x to the 4th. Once you take the square root, it moves to the outside and there's no more x's on the inside. Y to the 6th power is the same way. Y to the 6th power, if you divide that exponent by 2, you should get y to the 3rd. And I'm kind of running out of room, so I'm just going to write it below because I'm going to have to simplify it eventually anyways. So the square root of x to the 4th is x squared. That's what we have here. And the square root of y to the 6th is y to the 3rd. Once you take the square root, it is outside of that radical. Next we have z to the 7th. Now, you can't divide an odd number by 2 and expect to get a whole number. So we're going to actually split this apart to a z and a z to the 6th. You're always going to want to take only one variable out. That way you can take this variable and it ends up going inside that square root. And then the other variable we have with the exponent ends up going outside the square root because the square root, this is still under the square root, the square root of z to the 6th is going to be z cubed. So when we simplify all this, you see how I have all this outside? I just didn't have enough room. That's okay, I can fix that. 5 times 5 gets me 25. And then I have x squared y to the 3rd, z to the 3rd, and then square root of 3z. So all this is actually equal to our original. Now looking at the next example, there's a few different ways we can do this. We can combine these two as one fraction just with the square roots, simplify that and move from there. You can simplify the 200 on the bottom and then move from there. And those are probably the two options I would take. I'll be totally honest with you. I think I would rather actually simplify the bottom of the fraction first. I think. Well, it doesn't matter. Either way, we should get the same answer. So we can take a look at this here. I'm going to simplify the bottom first, just like I said I would. So if that's the case, my numerator will stay the same. The 200 can break up into 100, or the square root of 100, and the square root of 2. The square root of 100 gets me 10 over the square root of 2. I'm going to want to simplify that fraction. Notice how I have the 2 over 10. You can only simplify those two because they are not under a square root. That 2 over 10 can simplify to a 1 over 5. So that gives me a 1 square root 5 over 5 square root 2. The truth is, you really don't need this 1 there. It's not necessary. It's just an unnecessary coefficient. Now, remember that you are going to have to get rid of the square root of 2 on the bottom. You cannot have any fractions with a square root in the denominator. So what I'm going to do as a result is I'm going to multiply the top and the bottom by the square root in the denominator. That gives me square root of 10 on top, and that gives me 5 times the square root of 4 on the bottom. That gives me the square root of 10 over 5 times 2. So the square root of 10 over 10 ends up being my final answer. But the big question a lot of people ask me at this point is, what if we decide to do the other way? What if we go back and decide to combine this into one fraction and simplify that first? So that's exactly what we're going to do. We're actually going to work backwards. Now all the work is gone. We're going to start from fresh just like we were planning on doing. If you need to go back and see the work, of course, you can rewind the video and pause it and take a look. You can also listen to a recap of it. But at this point, what we're going to do is we're going to actually take this and put it under one big square root. And remember that 2 has to stay on the outside. And that 2 is going to end up with the numerator. So we get 5 over 200. And we're going to simplify that fraction. So we're going to get 2 times the square root of 1 over 40. I got 1 over 40 because this, if you divide the top and bottom of your fraction by 5, you get 1 over 40. Now, 1 over 40, remember our fraction rule, we can actually split this back apart if we want to. And we end up getting 2 times the square root of 1 over the square root of 40. Well, we already know the square root of 1 is just 1. So 2 times 1 will just give us 2 in the numerator. 2 over square root 40. So we're going to do the same thing like we did before. We're going to simplify that denominator. So when we simplify that denominator, we're going to figure out what is the largest square number that divides into 40. Well, that's going to be 4. So we can break that apart into the square root of 4 and the square root of 10. And that gets us 2 times the square root of 4 is 2, and the square root of 10. We cannot simplify that any further. A few more things now. So we have a few things going on here that we don't want to happen. Well, we don't want to have a fraction that's not simplified. I have 2 over 2. I can just simplify that and cross them out. So if I cross them out, that leaves a 1 on top. But I absolutely do not want a square root in my denominator. So I'm going to multiply the numerator and the denominator by whatever's in my denominator. That's square root of 10. So that gets me the square root of 10 over the square root of 100, because 10 times 10 is 100. And that simplifies to the same answer we got before, which is a square root of 10 over 10. So as long as you're following all the rules that I'm showing you, it really doesn't matter what you do first. It really doesn't matter if you simplify the 200 first like we did last time. It really doesn't matter if you turn it into one big fraction and simplify that and then go from there. Personally, I kind of liked the other way better. I thought it was less steps. I felt like it was a little bit easier to simplify. But really, it's all a matter of opinion and figuring out what you think is easiest for you.